Starting the second week, we've got day 5, 6, 7, and 8 coming up. And today we are going to talk about tuples and dictionaries. So last week we talked about lists towards the end of the week. And then today we're going to talk about tuples and dictionaries. And these are really similar to list in some ways. Tuples certainly are really similar. Dictionaries are a little bit different, but they serve similar purposes. And really they're all forms of what are called arrays, and these are just the ways that Python can interact with them. So a tuple is really similar to a list. It contains multiple elements just like a list does. These elements are indexed just like a list is. So if you did list 0, it would give you the first element. List 1 gives you the second element. Tuple 0 gives you the first element in the tuple, and tuple 1 gives you the second element in the tuple all the way in. You can also use other elements that you can with a list. You can use length. You can use the indexing and length. Those are the ones I remember right off the top of my hand. Let's see what else there is. And slicing. You can use slicing on a tuple also to get individual elements of it. But one of the biggest difference, actually the biggest difference to me, is that a tuple can store different data types. So remember when we were talking about a list, they all had to be the same data type. They all had to be integers, they all had to be floats, they all had to be strings, they could all be booleans. Whatever it was, they all had to be the same. Now in a tuple, they can be the same, and the tuple works fine like that. But if they're different, the tuple can still store them. Now, the issue with a tuple that's different is that it cannot be changed after it's created. So you think of it as like a read-only file. Once you create a tuple, that is the only thing that can be in it. You can't add values, you can't remove values, you can't change values. Once you create it, that is the entire thing. Now sometimes this is beneficial, right? Because for security purposes, there are some files, some data, some storage that you don't want to change ever. And if you make it a tuple, then it can't be changed. Now you can make it a list and you can protect it and you can put in checks to make sure that it doesn't get changed. But a tuple actually cannot be changed. So from a security standpoint, a tuple is good. But a lot of times when we make stuff like this, we need it to change, right? We're trying to update it to evaluate things along the way. In those cases, you would need to use a list. So, but all of the read functions work. We talked about length. They would give you the length of the tuple. Indexing will give you the individual value of a tuple. And slicing would give you the series within that tuple. Now, the difference between the notation. When you make a list, you're making a list and you're using square brackets. When you define a tuple, you're using parentheses. This is a pretty minor difference, but you'll notice when we get to dictionaries, they're a little bit different too. But the idea here is the interpreter knows what you're making because of the way, because of the syntax you use. And in this case, for a tuple, the syntax is parentheses. But when you get down to indexing and slicing, you're still using the square brackets because that's how those particular functions work. They're designed maybe more for a list, but with the idea that they still work with tuples. So even though the tuple is defined by parentheses, when you're indexing or slicing, you're using the square brackets. The next thing to talk about is the dictionary. So the dictionary stores values in pairs. It's got a key and a value. So if we look at this, the student is the key, and then the value is a person who is studying at school or college. Now the value, the key is going to be a string. In almost every instance, the key is a string, but the value can be anything. In this case, it's all strings, but it could be a float or an integer or a Boolean. It could be anything. It could even be a list if you wanted it to be. Now, the key can also be a list, but we're not. Most of the time, the key is going to be a string. The key could also be a tuple, I guess, if you're looking at it that way. But for the most part, it's going to be a string. So the idea is that you're treating it like it's a dictionary. This is the one on the left is the thing you're looking for. So you're flipping through the dictionary trying to find student. When you find it, it gives you the value of student, which is the definition in this course, in this case. So which is why we refer to it as a dictionary, because it has the thing you're looking for and then the definition associated with that, or the value associated with that. Now, the difference between a dictionary and a tuple, dictionary and a list, is you don't index the items. If you were to try to use an index as a 0 or a 1, it's not going to work. It's going to give you an error because these items are not indexed like that. The keys are the index, if you're looking at it that way. So this dictionary, you use graduate is the key, and then it tells you what the definition is. So that's a little bit of a difference. These things aren't indexed, so you can't use the zeros and ones. But if you know the key, then you can get the value. And we'll talk a little bit about what happens if you don't know the key, right? But comparing this to a list, right, if you're trying to look at an individual item, you have to have the actual key. But the key acts like its own variable. So you can go through and assign a new value to it. And I did that on the previous page. So if you're trying to assign a value to a key, then you use the name of the dictionary. And this is similar to the way we assign things in a list, right? The name of the dictionary and then the key. Now in a list, we would put 0, right? Because we would index it, maybe whatever the index was. But in a dictionary, we actually use the key, and then we can set it equal to a new value. So up here, successfully complete an academic degree, but if we were trying to change the value, we could with this formatting right here. Now, one thing about a dictionary that is different is that you can't have a duplicate value. So in a list or in a tuple, you can have 7 ones, or you can have 7 trues, or you can have 7 purples. It doesn't matter what the value is. You can have as many as you want as an element. But in a dictionary, each key acts like its own variable, and you can't create the same variable twice. So if you try to assign a new value to it, it's just going to override the previous value. It's not going to give you another item in the dictionary. It's going to override the one before. So if you want to remove some dictionary values, then you're looking at delete, and this also works in list, right? But you're deleting my dictionary and then the key value, whatever the key is. And this is going to delete both the key and the value pair. So in a dictionary, everything has a pair. Every key has a value associated with it. And if you delete one, it automatically deletes the other. You can't have a value without a key, and you can't have a key without a value. So my dictionary key will delete a specific key that you've chosen. So in this case, the keys, remember, are student, course, and graduate. I could delete any one of those by just delete this district or this dictionary dot in the square brackets. No, it's dot. In the square brackets, student. There we go. So delete my dictionary, and then in the square brackets, whatever the key is, we'll delete it. Another way to remove a key value pair is to use the pop item. This is my dictionary dot pop item. This is a little bit different because in the delete, you're telling it specifically which key you want to get rid of. But in pop item, it always gets rid of the last key and value pair from the dictionary. So the dictionary is ordered, and we'll talk about that a little bit later. Everything does have a location in the dictionary, and it knows which one is last. But you just don't access them through indexing. You access them through the keys. So pop item removes just the last element, the last item in your dictionary. Now you can pop as many items as you want, right? You can do this 7 times, and if you have 7 items in your dictionary, it'll get rid of all of them. Unlike the tuple, you can add and remove elements into the dictionary. So in this case, it creates a dictionary. 1 is the key, and then 1 is the value, 2 is the key, and 2 is the value, 3 is the key, 3 is the whatever. That's the original dictionary, and it's printing it. You're going to print original dictionary, dictionary 1, and then value delete, dictionary 1, you're going to pop an item. So this is printing what happens after you pop an item, and then it tells you what key value pair is removed, because you're creating a variable that stores the item that you pop out. So you can see how this would be useful. You move an item in and out, but you can access that through a variable. You could actually add it back in later if you wanted. But pop item kicks out both the key and the value. And you can do it again, pop item again, and see what it looks like the second time. Now, a little bit different from that is using the delete feature. You have the same dictionary, and you're printing the original dictionary, but you can delete dictionary and the 1 key, or delete dictionary and the 3 key. And that will just remove that 1 key, the 3, but also the value associated with it. So you have these codes here. Try and run them in onlinepython.com just to see what prints out, to hopefully get familiar with a little bit of the process. I'm going to keep going, and then I think this will probably be the last slide for this presentation. So when you remove a dictionary value, that's one thing, but you can also add a dictionary value. And this is where things get kind of important or kind of interesting, because if you couldn't add anything, you're restricted on what you can do or what you can use it for. But being able to add and remove values gives you a lot more flexibility. So again, because dictionaries aren't accessed by an index, you can add a new key just by using using the indexing format, but you have to have a key associated with it. So my dictionary, you give it the new key. It doesn't matter what the name of the key is, you create it. And then you give it the value of the key. In this case, I've used new value, which is a string, but your new key or your new value could be a number, it could be a float, or it could be a Boolean. It doesn't matter what the value is. But you add it with a key and a value. So really similar to every other variable we work with, the left side is telling you what the variable is, and the right side is telling you what the value is. The only difference is that this will now store it within that dictionary, and it doesn't store it on its own. Now again, if you attempt to add a new key, but that key already exists, it's just going to override the value for it in the dictionary. We'll look at some examples of this when we get into the actual coding today. I have a minute left, maybe a couple minutes. I'm going to start on the get function. I'm not going to finish it. But this is just a function that will access a key or access a value with a key, right? And we've already done that when we use print. We can access individual values, right? Or individual key value sets. So dictionary 1-3 returns the 3 and the 3 both here, right? That's what this formatting does. But if you were to use that format, and let's say you're looking for a dictionary 1-7, well, 7 doesn't exist. This is going to give you an error, and it's going to break your code. We have to have a system in place so that we can look for stuff in a dictionary, and if it's not there, we don't break the code. It just tells us it's not there. And that's what the get function does. So we'll talk about that in the next video in a little bit more detail, and then we'll go through the rest of the presentation. I think we'll get through it all in one more video. We'll look at some code, and then we're also going to do some code from last week, the project. We're going to go over it and explain all the steps. And that's where we're at right now. See you in the next video.